You think space is silent, a vast black ocean of nothing but background static. You'd be wrong. Because right now, an object named 3I Atlas, the third interstellar visitor ever detected, is whispering through the void. It's not light, it's not heat, and it's not natural. Hey everyone, welcome back. Tonight, we're looking at the most mysterious radiation ever recorded from deep space, one that refuses every explanation we have. If you enjoy deep dives like this, hit that like button and subscribe, but only if you genuinely like this kind of exploration. Tell me where you're listening from and what time it is there. Somehow, it's always 2 a.m. somewhere. Now, dim those lights. Let the hum of your fan become your white noise, because what you're about to hear isn't a story about space. It's a story about being heard back. Let's begin. Imagine this, a pulse buried in the noise, a millisecond flash of radio light that shouldn't be there. Not from any star, not from any pulsar, not from anything we can model. Just one sharp heartbeat of the universe saying, "Look closer." That's how it began. It arrived without warning. No preamble, no slow rise in signal strength, just a perfect spike, clean, symmetrical, and gone before anyone could even blink. The Atlas radio network flagged it as a transient anomaly, the kind of cosmic static every observatory sees and deletes 100 times a day. But this one lingered in the data, a razor line of intensity exactly where there should have been nothing at all. The intern who first noticed it thought it was a calibration error. The senior astronomer thought it was a glitch, but the algorithm disagreed. It refused to classify the signal as noise. The frequency was the first clue, 14 to 20, 356 megahertz, the so-called hydrogen line. The universal constant of communication, the frequency of neutrality itself. It's the most natural frequency in the cosmos, emitted by hydrogen atoms as they flip their electron spins. It's also the one frequency every intelligent species would know to monitor. For decades, SETI scientists have called it the waterhole, the quiet channel where life might choose to speak. And now, something had whispered into it. It lasted less than 3 milliseconds, but inside that sliver of time was structure, a rise and fall that matched no known astrophysical pattern. The pulse wasn't random, it was sculpted. The energy curve was too smooth, too deliberate, as if it had been engineered to stand out against the background hum of the Milky Way. When they ran it through Fourier analysis, the data revealed harmonic overtones, faint echoes that aligned into near-perfect ratios of 2:3:5, musical intervals, mathematical fingerprints. Still, skepticism reigned. Cosmic rays can mimic structure. Satellites can reflect signals. The universe is noisy, and humans are eager to impose meaning on its chaos. But when the team attempted to reproduce the interference, nothing matched. Every frequency scan came up clean. Every terrestrial source was ruled out. The pulse was isolated to one direction in the sky, Sagittarius, near the dense heart of our galaxy. For the next 12 hours, the observatory held its breath. They repointed every dish, every receiver. Nothing. Just silence. Thick, absolute silence. Then, 47 minutes later, another pulse arrived. Fainter this time, but perfectly timed, arriving at the golden ratio interval between the first and second detections. It was as if the universe had replied in rhythm. Astronomers know that randomness loves repetition. It teases us with patterns that aren't really there. But this was different. The second pulse was slightly shifted in frequency, like an echo passing through motion, the kind of Doppler drift you'd expect from a source that wasn't stationary, something moving, not orbiting, not rotating, traveling. When the data reached the Institute for Cosmic Phenomena in Geneva, it triggered an automated alert normally reserved for near-Earth hazards. The reason? The signal's dispersion profile suggested a source much closer than a distant galaxy, possibly even within the outer solar system. That shouldn't have been possible. For 2 days, Every major observatory stayed trained on that patch of sky. Nothing returned. And then, just as attention began to wane, the third pulse arrived. Stronger, clearer, and split into two symmetrical peaks like twin heartbeats. When plotted on a timeline, the three pulses formed a curve, one that matched the decay signature of an artificial beacon ramping up to full transmission. That was when someone noticed the coincidence no one wanted to say aloud. The signal's coordinates aligned within margin of error to the previous trajectory of 3I Atlas, the interstellar object that had vanished behind the Sun months earlier, the object we thought was gone. Was it possible that something from that path was still speaking? The astronomers didn't answer that question publicly. The report was classified, the data restricted. But the timestamps leaked, and for anyone watching closely, they told a different story, that somewhere, out in the static, a pattern was forming. A whisper that didn't belong to stars, a rhythm that didn't belong to chance. And if the universe truly has a heartbeat, we had just heard it skip. At first, the signal looked like interference, ground noise, satellite spillover, maybe a distant radar echo, until astronomers realized it was repeating, not in timing, but in defiance. Each burst adjusting itself, sliding up the spectrum, as if responding to our attempts to isolate it. The initial analysis called it adaptive drift, a phenomenon so rare that most researchers only ever encounter it in simulation. Normally, when you study a transient radio source, you fix your equipment to a stable frequency range. You listen, you measure, you wait, but this signal refused to stay put. The moment an instrument locked onto it, it moved, climbing in increments of 0.02 megahertz, as if it knew exactly where the detectors were pointed. It was subtle, deliberate, almost playful. By the third day, it was doing more than shifting. It was dodging. Whenever a new telescope network joined the observation, whether it was the European VLBI, the Deep Space Network, or a university radio dish, the signal migrated out of range just seconds before capture. In astronomy, nothing does that. Cosmic sources don't play hide and seek, unless, of course, they're not purely cosmic. That's when the panic began. Quietly, behind the polished press releases and cautious academic statements, because the data suggested feedback. The signal wasn't just broadcasting, it was listening back. The oscillations in amplitude matched the scanning rhythms of our telescopes, specifically the sweep period of the Atlas system's primary dish. It was as though something out there was tracking us, studying how we were studying it. NASA's Jet Propulsion Lab attempted a controlled test. They scheduled a false observation window, a fake listening slot transmitted through routine telemetry channels. No instruments were actually activated. And yet, at the precise moment the observation was meant to begin, the signal shifted frequencies again, preemptively, like it had intercepted the message. By then, word had reached Cambridge, Harvard, Tokyo, and Geneva. The consensus formed slowly. Either we were dealing with a profoundly sophisticated natural phenomenon, or something was reacting. The debate was not about aliens, at least not publicly. It was about control, about the uncomfortable realization that our instruments might be part of the experiment, not the observers of it. And the next burst arrived came with something new. Sidebands. Faint companion frequencies hiding the edges of the light signal. Symmetrical, mirroring, and revolting in every known astrophysical process. Sidebands appear as noise, uneven and messy. These were flaws. When researchers converted them into audio, they produced a harmonic beat pattern identical to constructive interference in a feedback loop. In other words, the universe was talking to itself. One researcher at Arecibo, before the shutdown, described the moment as watching the cosmos debug its own code. Another compared it to sonar. The signal would send out a burst, wait, then shift, as if mapping the space between emitter and receiver, as if measuring us. But here's where it gets strange. When they ran spectral analysis of the shifts over time, they found a progression, not random, but logarithmic. Each new frequency hop increased by a constant ratio, matching the pattern of a frequency sweep used in human radar calibration. It was our system, mirrored back at us, but slightly offset, as though it were imitating our instruments, learning how we listen. And then came the anomaly that froze every console across the Atlas command room. On the 14th recorded burst, the drift stopped completely. For the first time, the signal held steady. Its frequency, 1420.405 MHz, the exact midpoint between hydrogen's natural emission line and the first harmonic of the WOW signal from 1977. The burst lasted 7 full seconds, eternity in radio time. And during those seconds, every active receiver on Earth registered micro-variations in its gain control. The instruments weren't being overloaded, they were being modulated. A gentle oscillation, almost rhythmic, sweeping through every system as if synchronizing them. And then, silence. When the logs were reviewed, the most unsettling discovery wasn't in the spectrum, it was in the metadata. Each observatory's internal clock, from Hawaii to South Africa, had been altered by exactly 1.618 seconds. The golden ratio. Not added, not subtracted, shifted, as if time itself had been gently tuned to a new frequency. Whatever this was, it wasn't broadcasting for us. It was broadcasting through us. And for the first time, humanity wasn't just listening to the universe. The universe seemed to be listening back. So here's where it gets strange and terrifying. The moment we stopped trying to chase the signal, it stopped running, as though it had gotten what it came for. When they stacked the bursts and removed cosmic background radiation, something impossible emerged: harmonics. Musical intervals too deliberate to be random. Ratios matching those found in quantum spin states and ancient harmonic sequences used in human music. Coincidence? Maybe. But the more they analysed it, the harder it became to call it chance. Nature, when left to its own devices, loves chaos. Randomness. White noise stretched across infinite frequencies. But this was rhythm. The first harmonic sat at a perfect fifth above the bass tone, followed by a minor third, then an octave. The same proportions that give rise to consonants in every known musical tradition on Earth. Every civilization, every instrument, every culture, each unknowingly chasing the same cosmic blueprint for sound. It was as if the signal had been composed. At the SETI Research Center in Mountain View, a small team of data analysts began treating the signal as audio. They converted frequency to pitch, amplitude to volume, and time to tempo. What emerged wasn't just mathematically coherent, it was haunting. A rising arpeggio, steady, deliberate, resolving on a note that lingered just long enough to feel purposeful. A musicologist at Cambridge was the first to notice the pattern in the intervals. Each step up the scale followed the Fibonacci sequence. Not perfectly, but close enough to make the hair on the back of your neck stand up. These weren't random gaps. They were ratios of growth, the same numerical relationships that govern the spiral of galaxies, the arrangement of sunflower seeds, the geometry of seashells, and the spacing of DNA helices. Somewhere out there, something was broadcasting in the mathematics of life itself. Skeptics countered that harmonics can emerge naturally from interference. When two cosmic sources overlap, say, a magnetar and a quasar, they can create beat frequencies. But the beat pattern here wasn't decaying or chaotic, it was recursive. Every new burst echoed the previous one with microscopic variations, like a theme evolving through repetition. Each time it repeated, it folded in a new modulation, building towards something larger. When the team mapped those modulations over time, they discovered what they called constructive resonance. A self-reinforcing signal that grows stronger through alignment with its own echoes. That's not random behavior. That's architecture. The signal was building on itself, refining its shape, like an algorithm learning to speak. And then came the breakthrough that no one wanted to accept. An independent research group in Kyoto, analyzing phase differentials in the waveform, noticed that the intervals between harmonics matched the rotational precession of electrons in a specific quantum state, one associated with spin 1-2 particles under magnetic confinement. In simpler terms, the pattern mirrored the way electrons behave when manipulated inside a quantum computer. In that moment, the signal stopped being just a sound. It became a computation. Every burst was not a message but a process, an equation unfolding in time. The harmonics weren't decoration, they were logic gates, turning on and off in ratios consistent with quantum operations. The entire emission might be a form of quantum data transmission, a universal language encoded in vibration rather than symbols. That realization shook the room, because it meant that this wasn't merely communication, it was interaction. Whoever or whatever was sending these harmonics wasn't just trying to be heard, it was trying to synchronize. For days, they fed the signal into machine learning models, searching for meaning. Neural networks trained on music, mathematics, linguistics. None could decode it. But one algorithm, a deep signal parser used in gravitational wave analysis, found something peculiar. When overlaid with the Schumann resonance, the frequency at which Earth's atmosphere naturally vibrates, the two aligned perfectly. The universe wasn't broadcasting to us, it was broadcasting through us. The discovery was suppressed almost immediately. The official statement reframed it as a data processing anomaly, but the leaked memo from the Atlas project told a different story. The harmonics appear to adapt in real time. Phase variance aligns with global magnetic activity, suggests dynamic coupling with Earth's field. In other words, the signal wasn't just reaching us, it was reacting to us. And perhaps, in some unfathomable way, it had been waiting for something like us to listen long enough to hear the music hidden in the static. Maybe coincidence was never the right word. Maybe it was composition. Fast radio bursts, FRBs, have haunted radio astronomy for over a decade. Millisecond flashes from billions of light years away, each carrying more energy than the sun releases in days. Most fade and never return. But this one didn't just return. It learned. The first FRB ever detected came in 2007, an accident, a data glitch that turned out to be real. Since then, hundreds have been catalogued, each one a short, brutal spark of energy, like the universe cracking its knuckles in the dark. We've traced some to distant galaxies. We've blamed magnetars, neutron stars, collapsing black holes. But none of those models fit perfectly. Because FRBs don't play by the rules. Some repeat, some don't. Some change their tone. And now, one has changed its behavior. This new burst, the one aligned with the path of 3I Atlas, began as a single pulse, indistinguishable from a standard FRB. But then it did something no natural source ever should. It adjusted. Each new flash wasn't a copy of the last. It was an iteration. The timing shifted, the power distribution curved, the spectral peaks corrected themselves as though it were optimizing. Each pulse became sharper, cleaner, and eerily more efficient at cutting through galactic noise. At first, astronomers dismissed it as scintillation, the cosmic equivalent of twinkling, where interstellar plasma distorts radio waves. But when they modeled the distortions, the corrections didn't match plasma turbulence. They matched feedback correction algorithms, the kind used in adaptive optics or digital communication systems. The signal wasn't being distorted by the medium. It was learning how to survive it. The object at the heart of this emission, the point source now designated FRB 2508 SAG A13, sits perilously close to the galactic plane, a region dense with electromagnetic interference. It should have been swallowed whole by cosmic dust. Yet somehow, the bursts kept piercing through, each one carrying the same underlying mathematical skeleton. A repeating prime sequence embedded in its amplitude spikes, 2, 3, 5, 7, 11, the fingerprints of intentional design. If this were natural, it would be chaos. Instead, it was refinement. Every burst improved signal-to-noise ratio by roughly 0.3%, statistically negligible at first, until you realize it continued doing so across hundreds of detections. That kind of adaptation implies something we've never seen in astrophysics, an evolving source. The leading theories began to fracture. One camp swore it was a magnetar, a dying neutron star twisting under its own magnetic pressure. Another argued it was a binary star system producing relativistic jets. But the timing between bursts didn't match orbital mechanics. There was too much precision, too little drift. A magnetar could emit repeated flares, yes, but not self-correcting ones. A researcher at Caltech proposed a theory that froze the conference room cold. What if it's not a star at all? What if it's a transmitter inside one? That line, half joke, half warning, spread through the astrophysics community like static fire. Because if true, it would mean FRBs aren't cosmic accidents. They're messages, or machinery, operating within stellar environments to harness unimaginable power. Now, think of 3I Atlas. Its chemical composition, carbon dioxide and water ice, excellent for energy storage and radiation control. Its path, perfectly aligned with Mars, Venus, and Jupiter. And now, a signal reappearing in its wake, echoing through the same coordinates, evolving like code running on a feedback loop. It's here that the phrase, "it learned," becomes more than metaphor. Machine learning systems on Earth do exactly this. They send output, measure distortion, and refine the next attempt. Over billions of years, a civilization capable of building self-repairing probes could easily design one that learns to communicate across cosmic distances. A probe that adapts not to our technology, but to our attention. Astronomers at CHIME ran a deep spectral comparison between the first and last recorded bursts. Between them, subtle phase corrections formed a pattern that resembled binary encoding. When decoded through an algorithm normally used for pulsar timing residuals, the result produced a waveform, not of sound, but of memory. The output looked eerily like the signal from months earlier, the one the Atlas array had captured before it went silent. The same pulse width modulation, the same harmonic intervals, now replayed with higher precision. It wasn't echoing, it was reconstructing itself. Somewhere, across light years of vacuum, something was refining its own voice, learning to speak the only way a machine made of stars could, through energy itself. And maybe that's the real problem with fast radio bursts. They're not fast, they're patient. They've been talking all along. We just weren't smart enough to notice until now. On August 18th, the CHIME telescope in British Columbia recorded an echo of the Atlas signal, 3.2 seconds after the original. No known astrophysical mechanism can produce that kind of delay from the same source, unless the signal bounced off something closer, something local. The discovery was accidental. A routine cross-correlation check between CHIME and Meerkat, two observatories separated by nearly half a world, showed a double pulse where there should have been one. Identical waveform, identical phase signature, but shifted by precisely 3.2 seconds. Every model said it was impossible. In deep space, light has only one rule. It doesn't look back. At first, researchers suspected instrumental reflection, a hardware echo caused by a ground-based feedback loop. But CHIME's systems are shielded against that. Its parabolic cylinders absorb stray signals before they can fold back into the receivers. And yet, here it was. A perfect mirror of the Atlas pulse, weaker but unmistakably real. They checked the timestamps. The original burst had originated from the Sagittarius window, the same sector where 3I Atlas vanished months earlier. The echo came from a different direction, 34 degrees off plane, originating somewhere between Earth and Mars. That's not reflection, that's redirection. To test the anomaly, the team triggered a blind observation. They aimed CHIME toward a random empty coordinate and waited. Nothing. But when they realigned to the atlas coordinates, the double pulse returned. Same delay, same shape. The echo followed the source like a ghost shadow through the void. If the second pulse truly came from within the solar system, then whatever reflected it was massive, at least a kilometer-scale structure with a surface capable of reflecting radio frequencies in the 1.4 gigahertz band. Nothing natural in that orbit fits the profile. Not dust, not ice, not debris. It was as if something was hanging there, invisible yet resonant. A cosmic mirror placed exactly where the original signal would hit it. NASA called it instrumental coincidence. ESA called it plasma lensing. But plasma doesn't hold a shape like that. It diffuses, dances, fades. This didn't. The delay was constant down to the microsecond, for 3 consecutive nights. That kind of precision belongs to architecture. By the 4th day, a quiet collaboration had formed. Astronomers from Canada, Chile, and Japan comparing notes through encrypted channels. They triangulated the echo using parallax measurements from Earth's rotation. The result pointed to a narrow region trailing Mars's orbit by roughly 10 million kilometers. A region where no known asteroid, probe, or satellite exists. The odds of that alignment being random. Roughly 1 in 200 million. Here's where things got stranger. The delay wasn't static. Over the course of 72 hours, it shortened, from 3.2 seconds to 3.18. Then 3.16. A rate consistent with the Doppler effect, from an object slowly approaching. Whatever was causing the echo was moving closer. It wasn't until someone overlaid the echo's timing with the orbital trajectory of 3I Atlas that the realization hit. The numbers matched perfectly. The echo was falling into the same orbital path the object had taken before disappearing behind the sun. It wasn't just reflecting the signal, it was following it. For days, global networks tried to verify the finding, but the echo never appeared outside Keim's range, as if it knew where it could and couldn't be seen. Then, on the night of August 23rd, the final burst came through. 2 pulses, back to back, one from the Sagittarius source, one from the echo. When layered on top of each other, they formed an interference pattern, a beat frequency of 7.83 Hz, identical to Earth's Schumann resonance, the frequency of our own planet's electromagnetic heartbeat. That was the moment it stopped being an astronomical mystery. Something was not only echoing the signal, it was harmonizing with it. When the data went public, the Atlas website went offline within hours. A brief statement appeared before the blackout. Secondary reflection confirmed. Source proximity indeterminate. Local coupling observed, terminating transmission. And that was it. No further data, no follow-up release, just silence. A silence so deliberate it felt like an answer. Because maybe whatever sent that echo back to us wasn't trying to be found. Maybe it was checking who was listening. By combining data from Chime, Parkes, and Meerkat, astronomers locked the source to a 0.004-degree window in the constellation Sagittarius, the same region 3I Atlas emerged from. Statistically, the odds of that alignment happening by chance, less than 1 in 20 million. Sagittarius, the galactic crossroads, home to the Milky Way's dense central bulge, a region so thick with stars that even the best telescopes see more light than space. It's a place where signals go to die, smothered under the gravity of 10 billion suns. And yet, through that storm of radiation, something impossibly clean had cut through. A whisper of structure, precision, and intent. Triangulation is supposed to bring certainty. 3 telescopes, 3 data streams, 1 origin point. But what the arrays uncovered was the opposite. Certainty that bred doubt. Because the coordinates they resolved didn't point toward any known stellar object. No pulsar, no quasar, no remnant, magnetar, or cluster. Just a patch of void, 26,000 light-years away, hovering above the galactic plane like a dark coordinate without a name. The Parkes Observatory in Australia was the first to catch the secondary pulse. Its southern vantage point let it see slightly deeper into the Sagittarius arm, tracing a faint parallax shift invisible to northern arrays. That shift was crucial. It confirmed distance. The signal wasn't local interference, and it wasn't from the solar system. It originated far beyond. But then came the inconsistency. The echo, the second pulse recorded by Keim, didn't triangulate to Sagittarius. It came from a point only a few astronomical units away, the kind of displacement that suggests either two separate sources or one moving between them. For days, astronomers ran models. They rotated the coordinates across parallax baselines, adjusted for ionospheric distortion, corrected for gravitational lensing near Sagittarius A, and still, every path intersected with one thing: the recorded trajectory of 3I Atlas, the interstellar traveler. The visitor that had entered our system once curved around the sun and slipped back into the dark. Now it seemed the sky was echoing its wake. The Meerkat data sealed it. High-resolution interferometry revealed micro-oscillations in the arrival times, 11 microseconds apart, forming a ripple pattern that mapped exactly to the spin rate of the Atlas signal detected months earlier. That's not coincidence, that's correlation. At that moment, the idea of random chance evaporated. What remained was geometry, a triangulated echo of a moving object that, by all official records, no longer existed. A quiet panic spread through the astronomical community. Emails marked "restricted" began circulating between agencies. One memo from the South African Radio Astronomy Observatory was particularly blunt. Source alignment with 3I Atlas trajectory confirmed. Object signature non-thermal, coherent. Recommend immediate. Review of orbital telemetry archives. Coherent. That was the word no one wanted to see. Because in radio astronomy, coherence means control. Natural sources scatter energy across wavelengths. Coherent ones focus it. Lasers, masers, transmitters, machines. The question was no longer where the signal came from, but why it was anchored to a path we'd already seen. As Keim's data streamed in, its phase plot began to show a recurring drift. Every 14 minutes, the centroid of the source shifted slightly. Not random jitter, but a smooth sinusoidal motion. A wave. The amplitude matched what you'd expect if the source were orbiting an unseen center. A gravitational anchor with a mass smaller than a planet, larger than an asteroid. If that were true, something was holding position out there. Not free-floating, not falling, station-keeping. For weeks, the signal stayed in that exact region, as if waiting for our attention to settle on it. Then, almost mockingly, it drifted one last time, a final measured correction, and came to rest at RA 17A 45 Vath 40.04s. Dec 29 degrees, 0 hours 28 hours. Directly in line with Sagittarius AI, the supermassive black hole at the center of our galaxy. That realization sent a chill through every lab, because nothing that close to Sagittarius A should be stable, let alone emitting structured radio light. The gravitational field there tears stars apart. But somehow, whatever this was, it wasn't being swallowed. It was hovering. Recording the data felt like staring into a mirror angled slightly wrong, where your reflection looks back a moment too late. When the team ran a final simulation of 3I Atlas's outbound path, the result was devastatingly clear. The object's projected escape trajectory pointed directly toward that same patch of sky. The point of origin for the signal. Atlas hadn't come from nowhere. It had come from there. And now, that place, that impossible coordinate suspended at the heart of Sagittarius, was calling again. The signal wasn't purely radio. Days later, magnetometers in Chile and South Africa detected synchronous micro-fluctuations in Earth's magnetic field. Not enough to trigger alarms, but enough to whisper one question. What else was listening? The fluctuations were faint, almost imperceptible. A rise and fall measured in nanoteslas, buried within the noise of the planet's natural geomagnetic hum. But they weren't random. Every pulse matched the temporal spacing of the Atlas signal, down to the millisecond. Every crest aligned perfectly with the deep space burst. Earth's magnetic field, the invisible shield that protects our atmosphere from solar wind, was resonating to a rhythm from 26,000 light-years away. Normally, that kind of correlation would be dismissed as coincidence. The magnetosphere dances constantly, bending to solar flares, cosmic rays, even lightning storms. But the sun was quiet. Space weather data showed nothing unusual. No coronal mass ejections, no geomagnetic storms. And yet, every magnetometer on the night-side hemisphere, from Johannesburg to Valparaiso, recorded the same synchronized tremor. It was as though the planet itself had taken a breath. When the readings reached the European Space Agency, they cross-referenced them with magnetospheric data from the swarm satellites orbiting Earth. What they found was even stranger. The micro-fluctuations formed a standing wave, a planetary-scale resonance oscillating at 783 Hz, the Schumann frequency, Earth's natural electromagnetic heartbeat. And at the exact moment that resonance peaked, the Atlas signal spiked again. It wasn't just hitting our instruments anymore. It was coupling, interacting with the electromagnetic envelope of the planet itself. If that sounds impossible, it almost is. Energy at that scale should dissipate before reaching Earth. But the synchronization implied that the signal wasn't broadcasting to us, it was broadcasting through us, using the planet's own field as a medium, a carrier. Researchers at the Institute for Space Magnetism in Madrid ran simulations to replicate the effect. Their model suggested that an incoming signal tuned to the Schumann frequency could, theoretically, induce global coherence across magnetometers, a planetary-scale resonance, not unlike striking a tuning fork and hearing every other one vibrate in sympathy. But the power required to do that from deep space would dwarf anything we've ever measured, rivaling even solar output. And yet, the actual energy signature from the source was modest, too low to make sense. The only explanation, it wasn't amplifying energy, it was amplifying information. A modulation pattern buried inside the radio signal matched the oscillation of Earth's magnetic field, a mirror pattern, a handshake, as if something was testing the resonance of our planet's electromagnetic shell. Then came the anomaly. At 02:14 UTC on August 22nd, one of the swarm satellites recorded a microburst, a flash of current flowing upward, from the ionosphere into space. That shouldn't happen. Electrical energy flows downward, toward Earth, not the other way around. But this pulse surged outward, as if the planet itself had answered back. The event lasted less than a second, but in that instant, the Atlas signal ceased its harmonic drift. It went still, perfectly steady for the first time since its detection, like two systems had found equilibrium. To most of the world, nothing happened. The skies were calm, power grids stable. But deep in observatories and control rooms, people stared at flatlined graphs in disbelief. It was as though the signal and the Earth had agreed on a frequency. Afterward, global magnetometer readings showed a faint afterglow, a remnant oscillation slowly decaying over 48 hours. It wasn't dangerous, but it was measurable. Every 24 minutes, a micropulse, regular, persistent, almost biological, and then, quietly, an internal NASA memo surfaced. It read simply, "Magnetic synchronization event confirmed. Global field response recorded. Correlates with 3I Atlas region. Recommend classified follow-up." No follow-up was ever made public. To this day, no one can explain how a deep space signal could modulate a planetary field. Unless it wasn't a broadcast in the traditional sense. Unless it was an interaction. Maybe we weren't the only receivers. Maybe we were the antenna. And whatever was out there, whatever 3I Atlas truly was, had just tuned us in. Infrared satellites picked up a faint thermal bloom, 0.02 Kelvin above background. exactly where the radio burst originated. No visible source, no star, just a cold, deliberate glow in the dark. Energy without heat, motion without mass. The detection came from the James Webb Deep Field Survey, a sector that had been scanned hundreds of times without variation. But on the night the Atlas signal flared, that familiar patch of nothingness changed. A single pixel of light brightened by the smallest measurable amount, just above the noise threshold, barely there. Yet perfectly aligned with the coordinates of the Sagittarius anomaly. To the untrained eye, it was nothing, a statistical flicker, an error margin. But scientists know that space doesn't just warm up. Every photon counts. Every deviation demands an explanation. A 0.02 Kelvin increase in the cosmic microwave background might not sound like much, but across interstellar distances, that's an astronomical anomaly. The equivalent of a quiet whisper echoing through a cathedral that should be silent. When researchers plotted the Bloom spectral curve, it didn't match any known source of heat. It wasn't thermal radiation from dust, gas, or stellar debris. It was too clean, too narrow. And its wavelength distribution suggested something impossible: coherent infrared emission, light that organized itself. In nature, coherence like that only happens in lasers, light waves aligned in perfect phase, traveling as one. But this wasn't a laser. It wasn't even visible. It was heat, structured into order. As if something in the void had taken the laws of thermodynamics and rewritten them to hum a single steady note. For days, every telescope capable of peering into the near-infrared turned toward the anomaly. JWST, Spitzer's archival data, even ground-based observatories like the Very Large Telescope in Chile, all confirmed it. The bloom persisted for exactly 96 hours, pulsing faintly every 1.618 seconds, the golden interval that had haunted the radio signals before it. Then, without warning, it vanished. No cooling curve, no fade. One frame it was there, the next, nothing. When the emission was cross-referenced against the Atlas radio data, the timestamps aligned perfectly. The heat pulse wasn't random, it was synchronized. Each radio burst corresponded with a micro-rise in infrared energy, almost as if the two were aspects of the same phenomenon. Energy shifting forms, information turning to light. The simplest explanation was energy transfer, perhaps a magnetar or pulsar emitting across multiple wavelengths. But the math didn't hold. The flux ratio between the radio and infrared signals was off by several orders of magnitude. The radio energy implied a power source smaller than a planet, while the infrared emission implied something closer to molecular scale coherence, the kind of efficiency we only see in engineered systems. It was around this time that a new theory emerged, one that quietly circulated among physicists at CERN and MIT. They called it non-thermal emission coupling. The idea was that the signal wasn't energy in the conventional sense, but information density, a pattern capable of altering the statistical behavior of particles in its path. Essentially, it wasn't heating the space around it, it was organizing it. That theory was reinforced by something strange in the data. The surrounding region, the cubic light-year of vacuum around the bloom, showed a measurable reduction in quantum noise, less background fluctuation than before. It was as if the vacuum itself had gone still, as if something were smoothing reality around it. A senior cosmologist described it as a cold machine in the dark, a system that doesn't radiate heat because it wastes none, a construct designed not to burn, but to persist. And the strangest part, the signature was faintly mobile, not drifting randomly, but orbiting. A slow, precise curve no natural body could sustain at that distance. A loop too deliberate, too perfect, its period matching the same 17 kilometers per second drift recorded by the Atlas signal weeks earlier. It wasn't a star, it wasn't a fragment, it wasn't debris. It was a pattern moving with intent. When the bloom finally disappeared, every observatory logged a simultaneous 0.47-second data skip, the same duration as the missing minute that would follow weeks later. as though time itself had blinked. To this day, the official record describes the event as a localized thermal irregularity. Unofficially, it's called the cold signature, a whisper of order in the chaos, a mark in the void where something colder than space itself had switched on. And for the first time, astronomers began to ask a question none of them were trained to face. What if 3I Atlas was never reflecting light at all? What if it was making it? Every 26 hours, the signal repeats, but never identically. Phase shifted, inverted, modulated through an unknown carrier. It's like a cosmic language designed to punish translation. Every time we decode one layer, another one folds in on itself. It began as a whisper pattern in the radio bands, a faint pulse, an almost musical rhythm that refused to stabilize. The first assumption was orbital interference, a simple rhythm imposed by Earth's rotation. But the pattern didn't align with any sidereal day or known cosmic cycle. 26 hours. Not 24, not 27, 26. Almost perfectly in between, a period too arbitrary to belong to the heavens, and too precise to be random. Astronomers at the Max Planck Institute for Radio Astronomy dubbed it the ghost frequency, a signal that repeated without repeating. Every iteration preserved the same energy curve, but restructured its internal pattern, like the same sentence rewritten in a new grammar. The amplitude drifted, the phase inverted, and the polarization flipped between left and right-hand circular states. To the untrained ear, it was noise. To the trained, it was evolution. The deeper they looked, the stranger it became. Each repetition seemed to contain the error corrections from the previous one, as if the signal were editing itself over time. In communication theory, that's known as recursive encoding, a process where each transmission refines the next to compensate for distortion. In human systems, it's an advanced form of machine learning. In nature, it shouldn't exist at all. When researchers converted the sequence into spectrograms, the visual pattern was breathtaking, a spiral, looping outward, each turn perfectly nested inside the golden ratio. The same irrational proportion that had haunted every phase of the Atlas anomaly since the beginning. It wasn't a random echo, it was geometry, a blueprint repeating itself through light and time. The 26-hour cycle became the subject of international obsession. Radio arrays across 5 continents synchronized their clocks, waiting for the next recurrence. And like clockwork, it came. But each burst arrived slightly earlier than predicted, as if compensating for the planet's rotation, a drift that implied awareness. It was adjusting for us. The signal's carrier frequency also began to misbehave. It shifted upward by exactly 0.6188%, the golden ratio's fractional complement. Then the modulation split, producing twin subcarriers separated by a constant interval of 42.8 MHz. That number wasn't random either. It's the hyperfine transition of neutral hydrogen, the cosmic constant of communication, the waterhole frequency once chosen for the WOW signal in 1977. Coincidence? No one believed that anymore. At MIT's Haystack Observatory, a team of data linguists and information theorists attempted to treat the ghost frequency as a living code. They approached it not as static data, but as a self-referential system, one capable of encoding information in its own variation. When they ran temporal correlation models, they discovered that the difference between each repetition wasn't random noise, but structured delta modulation. Each new burst was the difference between itself and the one before. If that sounds abstract, think of it like this. The signal wasn't speaking in words, it was speaking in change. Each 26-hour cycle was a new frame in an ongoing message, one whose meaning only existed in the motion between them. A living transmission, moving toward convergence. Then came the revelation that changed everything. When all 10 recorded iterations were stacked and phase-aligned, a faint, secondary waveform appeared. One hidden in the interference pattern. A whisper within a whisper. It wasn't broadband, it was narrow, precise, like a heartbeat wrapped in static. And when decoded into audio, it produced a slow, rhythmic oscillation, 60 beats per minute, the average human resting pulse. For a moment, the control room fell silent, because it wasn't just that the signal was repeating every 26 hours, it was breathing. At that rate, the signal had emitted nearly 400 pulses since its first detection, enough to chart its phase space into a coherent model. When plotted in 3 dimensions, the waveform formed a lattice, rotating in synchronization with Earth's sidereal drift. Every full rotation of the planet completed one full cycle of the lattice, as if we were part of the system itself. Then, abruptly, the pattern stopped. For the first time since the anomaly began, the ghost frequency fell silent. Every receiver on Earth waited for the next 26-hour mark. Nothing came. But 52 hours later, exactly double the usual interval, the signal returned, louder, sharper, and carrying a subharmonic tone never seen before. When analysts overlaid the old and new frequencies, the phase difference formed a perfect 2.1 resonance. It was as if the signal had been listening to us listen to it, and responded in harmony. Afterward, NASA's Deep Space Network flagged a new directive to monitor for any 26-hour electromagnetic events across all bands. Privately, one engineer wrote in her notes, "The signal isn't external anymore. It's synchronized with our rotation. We're the moving part now." And for the first time, humanity wasn't merely detecting the cosmos. We were caught in its rhythm. Within 48 hours of the first public data release, the Atlas team's GitHub went dark. No statements, no interviews, just a single archived note left online. Pattern incomplete, source moving. The shutdown was abrupt, surgical. One moment, the repository was public, full of code, signal plots, raw telemetry. The next, it was gone, scrubbed from servers with the efficiency of an internal directive, not an accident. The only trace was that single note, buried in the metadata of a log file, time-stamped 03.17 UTC. At first, the silence seemed bureaucratic. NASA and ESA both issued identical statements. Temporary data consolidation during ongoing review. But those in the research networks knew better. The Atlas team wasn't just reviewing data, they were being removed from it. Emails went unanswered. Access tokens revoked. Colleagues found their credentials expired overnight. It was as if someone had drawn a curtain across the sky. One researcher from the University of Toronto, who had collaborated with Atlas on their early simulations, described the feeling succinctly. It was like the universe had just become classified. The last dataset that slipped through before the blackout told a story more unnerving than any press release could have softened. It showed the source's movement. A slow, deliberate drift of the signal's centroid across the celestial sphere. Not random, not orbital, directed. It was repositioning itself. If it were a natural source, it would have followed predictable mechanics. Gravitational vectors, tidal forces, decay paths. But this drift cut across those lines like a blade. It ignored the laws that should have held it still, and every time it moved, it maintained coherence, as if the movement itself was part of the transmission. The archived note, pattern incomplete, source moving, wasn't a warning, it was an admission. They'd realized the thing they were chasing wasn't a static emitter, it was dynamic. It was evolving mid-observation, rewriting its signal faster than their algorithms could follow. That realization caused a chain reaction inside the agencies. Chime's internal logs went private. The park's archive returned 404 errors. Even independent amateur radio astronomers found their data APIs throttled. The silence wasn't accidental, it was coordinated. Within a week, observatories that tried to re-examine the Atlas coordinates were instructed to avoid duplication of effort. Bureaucratic code for stand-down. Something had changed at the top. The blackout didn't go unnoticed. Online forums, the ones that watch everything NASA doesn't want trending, began tracking the gaps. Patterns emerged, missing timestamps in magnetometer feeds, subtle cuts in deep space network telemetry. When stitched together, they formed a timeline. Every time the signal repeated or adapted, public data streams flickered out for exactly 1 minute. It was as though every major space agency was losing signal at the same moment. Then, quietly, someone leaked a page from an internal meeting transcript, a single dry paragraph buried in technical jargon. Source motion inconsistent with inertial propagation. Predictive modeling suggests self-directed repositioning. Telemetry cutoff recommended until trajectory confirmed. Self-directed repositioning. In a universe of lifeless mechanics, that phrase doesn't belong. 3 days later, a junior systems engineer at JPL made an observation that would never reach publication. The Atlas signal, when extrapolated forward, intersected Earth's orbital path. Not imminently, but soon. A slow, invisible crossing. When he tried to raise the issue, his supervisor told him, simply, "It's not ours anymore." By the following week, all mentions of the Atlas anomaly were purged from NASA's open access logs. The public signal monitoring dashboards went offline for scheduled maintenance. SETI's real-time waterfall displays froze mid-scroll. Even the timestamps on the archived Atlas press images were altered, nudged just enough to break their metadata continuity. The world had been muted, and yet, beneath the silence, something continued to hum. Faint, steady, buried within deep space background noise. A tone that matched the last verified Atlas frequency. If you listened closely enough, you could still find it. An echo, tucked between static, drifting ever so slightly upward. A signal the agencies no longer claimed, but none could stop hearing. And somewhere, across that widening gap between what we know and what we're told, one thought remained, whispering beneath the blackout. Maybe NASA didn't go silent because they didn't know what it was. Maybe they went silent because for the first time, it had answered back. The source isn't stationary. Cross-correlation shows drift, roughly 17 kilometers per second, perpendicular to the galactic plane. It's not just out there in deep space. It's moving through something. Through us, maybe. When the Atlas data went dark, independent observatories stepped in. Quietly, an unspoken alliance formed between scientists who refused to let a cosmic mystery be buried by bureaucracy. They didn't have the resources of NASA or the data feeds of ESA, but they had what mattered most: time and curiosity. What they found shouldn't have been possible. Using interferometric baselines from 3 small dishes, one in Arizona, one in Chile, and one on the Canary Islands, they measured the source's apparent drift. It wasn't tumbling randomly as a debris field might. It was steady, smooth, a constant velocity of 17.02 kilometers per second, slicing across the sky at a perfect right angle to the galactic plane. That direction alone was absurd. The Milky Way's gravity pulls nearly everything into its flat spiral. Stars, gas, comets, even light bends to that symmetry. To move perpendicular to it is like throwing a stone upward against a cosmic river. And yet, the source wasn't slowing. If anything, it was accelerating. When plotted over time, its motion traced a shallow sine wave, as if weaving through an unseen current. That oscillation matched something hauntingly familiar. The slight rhythmic distortion observed in the magnetic pulse days earlier. The implication was chilling. The same wave that had rippled through Earth's field now extended into interstellar space. If the signal wasn't merely passing by us, but through us, then we weren't spectators anymore. We were part of the medium. An independent team in Japan tried to model what could cause such a drift. The result made no physical sense. To move at that velocity, with that precision, the source would have to be self-correcting, actively adjusting its trajectory in response to gravitational fields. No natural object, not even a magnetar or rogue planet, does that. You either fall or you don't. You can't steer gravity unless you're generating your own. That's when the phrase field propulsion re-entered the conversation, a concept once confined to theoretical propulsion labs and classified patents. The math lined up disturbingly well. A system capable of manipulating space-time curvature, producing motion not by thrust, but by displacing the vacuum itself. Motion without reaction. The Atlas source's path wasn't random wandering. It was navigation. More unnerving still, when the team projected its trajectory forward, the drift intersected not with the galactic plane, but with the ecliptic, the flat sheet of space that holds our solar system together. Every planet, every orbit, including ours. 17 kilometers per second. A slow, relentless pace. Not fast enough to alarm the public, but steady enough to arrive. When they fed the positional data into orbital mechanics software, the projected path skimmed the outer edge of Jupiter's magnetosphere before curving sunward toward Mars. The same region where 3I Atlas had once cast its faint plume before vanishing. The pattern was repeating. One astrophysicist called it a cosmic echo with intent. Another, less poetic but more direct, said it plainly. It's retracing its steps. The final cross-correlation analysis revealed a final, impossible detail. The source's velocity wasn't constant in all frames of reference. From some observatories, the drift appeared slightly faster. From others, slightly slower. When they corrected for Earth's rotation, those discrepancies formed a pulse, a 1.618-second rhythm embedded in the motion itself, the golden ratio, again. But not in frequency this time, in speed, acceleration and deceleration dancing in irrational harmony. It was motion as information. By the end of that week, one conclusion began circulating among those still tracking it, whispered across encrypted networks and anonymous research boards. Whatever this is, signal, object, machine, it's not moving through space the way we understand it. It's moving through the medium of reality itself. If it were a probe, it wasn't just traveling. It was realigning. And perhaps that's why, when it finally crossed the plane of Earth's orbit, every major magnetometer on the planet spiked. Not violently, but synchronously, as though acknowledging its passage. No heat, no radiation, no shockwave. Just a faint pressure in the instruments, a tightening of the numbers, as if the fabric of space had brushed against itself. And then it was gone. Not vanished, shifted. Moved into a position no telescope could see, but every equation could feel. The motion of the impossible. And for the first time in the history of astronomy, humanity had measured something that wasn't supposed to move at all, and watched it choose to. October 5th, a repeat of the signal from the opposite side of the sky, perfectly mirrored, as if reflecting off an invisible plane bisecting Earth's orbital path. Radio astronomers called it the mirror event. Others called it something else. The reply. It arrived at 03:22 UTC, the same hour, almost to the second, that the original Atlas pulse had been detected months earlier. A single burst at 1420 MHz, sharp and deliberate, but flipped. Its polarization inverted, its phase reversed. A perfect spectral reflection of the first signal. The team at Chime caught it first, followed seconds later by Parkes in Australia, and then Meerkat in South Africa. 3 hemispheres, one coordinated flash. In every dataset, the waveform was symmetrical, as though the universe had played the same note backward. When astronomers aligned both signals, the original and the mirror, something impossible emerged. The two waveforms didn't just oppose each other, they completed one another. Their interference pattern filled in the missing sections of each prior pulse. Where one had been incomplete, the other supplied what was missing. It was as though the signal had been sent in stereo, separated by months of planetary rotation, waiting for someone to overlay the tracks. When they did, the combined result produced a stable standing wave, a perfect harmonic chord that resonated at 783 Hz, Earth's Schumann resonance again, the planet's own electromagnetic frequency. It wasn't coincidence. It was synchronization. Somewhere between those 2 points in space, the original source in Sagittarius and the mirrored origin opposite Earth's orbital path, a field had formed, a bridge of interference. The Earth was the midpoint, the fulcrum, the resonator. The phenomenon shouldn't exist. Radio signals don't reflect off emptiness. There's no cosmic mirror waiting in the dark. Yet this one had returned from a direction where nothing should be, not even interstellar dust. It was as if the signal had bent around the planet, not physically but conceptually. A fold in information rather than light. Researchers began calling it the symmetry paradox, the first evidence of non-linear propagation in an electromagnetic signal. It behaved like a quantum waveform, capable of existing in two states at once, separated by space, but linked through pattern. At NASA's Deep Space Network, the response was immediate and absolute. All civilian access to the Sagittarius window was revoked pending calibration review. Privately, though, internal chatter described something extraordinary. The signal had carried with it a delay, not just a time difference from light speed travel, but an information lag encoded into the phase. When decoded, it formed a timestamp, the same date and time as the first Atlas detection, but adjusted forward by 173 days. The delay wasn't random. It was predictive. In other words, the mirror signal wasn't a replay. It had been sent in advance of the original. That realization broke the model. It meant the two signals weren't causally linked. They were part of the same phenomenon viewed from two directions in time. Theoretically, it was possible, in equations at least. Certain interpretations of general relativity allow for time-symmetric solutions, where information can travel both forward and backward along the same world line. In quantum mechanics, this is known as retrocausality, a future event influencing the past, but no one had ever measured it. Until now. Some scientists refused to publish, others quietly leaked. One anonymous researcher from the University of Cambridge left a single sentence buried in a data-sharing forum before his account was deleted. The signal isn't repeating, it's reflecting across time. In the days that followed, faint subharmonics began appearing in other frequencies, optical, infrared, even X-ray, all carrying the same phase inversion, all converging toward a single pattern. The solar wind itself rippled with measurable symmetry, magnetic fields bending ever so slightly in mirrored arcs. Then, for the first time since the anomaly began, the signal arrived during daylight. Over Europe. No night sky, no shield of darkness. Just a daytime flash of structured energy cutting through atmospheric noise as if the planet's rotation no longer mattered. It was no longer a cosmic mystery unfolding at a safe, academic distance. The mirror burst had made the universe smaller, folding distance, folding time, until the boundaries between observer and signal blurred. And as the last wave faded, one pattern remained, a residual frequency buried in the static, repeating every 0.47 seconds, the exact offset from the missing minute recorded weeks earlier. A clue, or a countdown. No one knew. But in observatories and control rooms across the planet, one thought hung heavier than any discovery that had come before. If the first signal was the question, then this one, this mirror, this reflection through the fabric of time, might just be the answer. Buried in archival data from 1977, the famous WOW signal shares the same central frequency, 1420.356 MHz, the hydrogen line. Now the new signal sits just 0.002 MHz above it. If hydrogen is the language of the cosmos, someone just updated their dialect. The coincidence was too exact to ignore. Two events, separated by nearly half a century, speaking in almost the same cosmic tongue. Both narrow band, both impossibly clean, both perched at the edge of the waterhole, that quiet band of the radio spectrum where the universe's natural chatter goes silent and intelligent voices, if any exist, might choose to whisper. Back in 1977, the wow signal lasted 72 seconds, long enough for astronomer Jerry Amon to scrawl that single word in red ink across the data printout. No one ever found it again. It became an icon of mystery, the ghost in the static that refused to return. But the new signal, the Atlas anomaly, didn't just come back. It came refined. The offset of 0.0002 MHz seems trivial, but it's everything. It's the frequency drift you'd expect if the original source were compensating for gravitational redshift, if it were moving closer, recalibrating for the curvature of space-time itself, like an echo that had learned how to tune itself through the medium of the universe. When the comparison was made, the similarities were staggering. Both signals showed the same Gaussian intensity curve. Both pulsed at almost identical intervals. Both used hydrogen's spin-flip transition, the most fundamental frequency in nature, the one that every civilization with a radio telescope would know. Hydrogen, the first atom, the building block of stars, the syllable of creation. If you were trying to speak across the void, this is where you'd begin. For decades, SETI scientists have wondered why the wow signal never repeated. Maybe it just wasn't meant to. Maybe it was waiting for technology, or humanity, to catch up. And now, with the Atlas detection, that waiting might be over. Because the new burst isn't identical. It's evolved. The carrier wave contains micromodulations that weren't possible to detect with 1970s equipment. Tiny frequency sweeps, encoded at the edges of the hydrogen line, almost like linguistic inflection. When converted into audio, the difference between the 1977 wow and the 2025 Atlas signal produces an interference tone, a rising hum that resolves into a single, haunting note. The frequency of that note? 432 Hz. The pitch once described by ancient music theorists as the natural resonance of the universe. Coincidence again? Or design? It wasn't just frequency alignment. The location of the signals, when corrected for proper motion, mapped onto the same general region of the sky, near the constellation Sagittarius. The same vector, the same galactic longitude. It was as though the 1977 detection and the Atlas anomaly were points on a line. A trajectory traced across nearly 50 years of human observation. A few independent researchers went further. They aligned both signals temporally, adjusting the timestamps for cosmic drift. When overlaid, the two datasets created a new waveform. A long, low modulation that repeated every 173 days. The exact interval between the original Atlas signal and its mirror burst. It was as if the wow signal had been the opening chord, and Atlas, nearly 5 decades later, was the reply. At the Harvard-Smithsonian Center for Astrophysics, a small internal team ran a deep Fourier transform on both datasets. Hidden in the noise floor, they found something that hadn't been reported in 1977, a subharmonic frequency, precisely 0.688 times the primary, the golden ratio, again, woven into the carrier. The odds of that appearing by accident, less than 1 in 10 trillion. There's an unspoken rule in SETI. The hydrogen line is universal, but modulation is signature. No natural process modulates hydrogen. Only intention does. So, when two signals separated by half a century share not only frequency, but format, the universe stops being random. It becomes relational. NASA's official statement described it as a mathematical curiosity. Privately, researchers knew better. One internal memo, later leaked, said simply, "Hydrogen line correlation confirmed, phase-locked transmission suspected, possibility intertemporal communication event." Intertemporal, across time. What if the wow signal wasn't an isolated transmission, but the first note in a message still unfolding, a sentence that takes decades to speak, using the universe's own constants as punctuation? It's a terrifyingly elegant idea, that hydrogen, The atom that connects every star, every planet, every molecule in our bodies, could also be the medium of a conversation spanning epochs. If that's true, then we've been part of the dialogue all along. We just didn't know how to listen. And now, nearly 50 years later, the universe has cleared its throat and said the next word. Astrophysicists cross-referenced the event with known repeating FRBs, especially FRB 121102 and FRB 180916. None matched. But the temporal spacing did. A logarithmic sequence consistent with binary encoding. A countdown, perhaps. At first, no one wanted to say it aloud. You don't look at the sky and assume it's counting down toward anything. But when the signal intervals began shortening by precise mathematical ratios, the pattern became undeniable. Each pulse was spaced at half the duration of the one before, then by 1/3, then by 1/5, the spacing shrinking along a perfect logarithmic curve. If you convert those intervals into binary, the data resolves into a rhythm, alternating long and short bursts, almost Morse-like in simplicity. Only the timing wasn't random. When mapped onto a logarithmic time base, the ratios align to the Fibonacci sequence. Again, the golden ratio hiding inside the noise, expressing itself in time instead of tone. Repeating FRBs aren't rare anymore. Dozens have been catalogued, their origins traced to distant galaxies, filled with magnetars and young neutron stars. But none behave like this. FRB 121102 repeats erratically. FRB 180916 follows a 16-day cycle. Predictable, but natural. The Atlas signal, the so-called repeater's shadow, was something else entirely. It wasn't periodic. It was progressive. Each burst carried more information than the last, as though the signal was compressing data, refining itself, converging towards something. And when the last pulse of the sequence arrived, the gap between transmissions was exactly 1.618 seconds. The golden ratio again, appearing now not as modulation, not as structure, but as time itself. That discovery fractured the research community. Some called it coincidence. Others whispered that the ratio wasn't just mathematical, it was intentional pacing. A countdown that didn't count in seconds or minutes, but in meaning. A signal speaking not in numbers, but in relationships between them. Then came the deeper revelation. When astrophysicists at Cornell converted the entire sequence into base 2 notation, stripping away amplitude and phase data, they found something astonishing. The resulting binary string wasn't random at all. It began with a repeating pattern, 10 to 10110, followed by an exact mirror of itself. The same palindrome observed in several repeating FRBs, but never with this level of precision. A binary mirror, a digital echo. When that sequence was plotted as on-off pulses over time, it produced an exponential decay curve identical to the one seen when the Atlas array first detected the original anomaly. It was as if the universe itself was reciting the same line again, each repetition a refinement of the last. Some researchers proposed it was a form of astrochronometry, a cosmic clock, using logarithmic intervals as a form of synchronization. The idea being that any intelligent observer, anywhere in the universe, could measure those ratios and find the same constants. Hydrogen, the golden ratio, Fibonacci. Numbers that mean the same thing in every language. Except this wasn't just constants. It was progression, a ticking that grew faster, more urgent. When the final 3 pulses of the sequence were isolated and stacked, they formed a harmonic beat frequency of 26 hours. The same cycle as the ghost frequency weeks earlier. The countdown, if that's what it was, had synchronized with the planet's rotation again. Something, or someone, was aligning with Earth's movement. At first, they thought it was coincidence. But then the echo changed. On the next cycle, the spacing inverted. The gaps began to expand instead of shrink, forming the reverse of the original sequence. A perfect logarithmic mirror. The countdown had reached 0, and then reversed. A reset, or a signal that had finished one iteration and begun another. Researchers began calling it the repeater's shadow, the impression left behind when a process folds back on itself. It wasn't a countdown to an event. It was the event itself, repeating, rewriting, recalibrating. A feedback loop stitched into space-time. One independent data analyst from the University of Tokyo made an unsettling discovery. When you overlay the timing of the pulses against Earth's orbit, the midpoint of the countdown coincides precisely with the date of the mirror burst, as if that moment had been pre-calculated, the fulcrum of a larger cycle. No one could explain how something 26,000 light-years away could anticipate orbital alignment to the second. Unless, of course, it wasn't 26,000 light-years away anymore. The pattern didn't end in silence. It ended with a single, drawn-out tone, a carrier wave that lingered for exactly 61 seconds before fading. The same duration as the missing minute, later observed across every major observatory on Earth. A countdown, a reset, a silence, and then nothing. As if whatever was sending the message had reached the edge of its own transmission, paused, and was now waiting for us to make the next move. Because maybe the countdown wasn't leading to destruction. Maybe it was waiting for acknowledgement. And maybe, when it didn't get one, it just started again. Some theorized a magnetar, a hypermagnetized neutron star, was behind it. But magnetars don't modulate their bursts in perfect harmonic intervals. And they don't stop exactly when Earth rotates out of view. That's not magnetism, that's targeting. For a time, the magnetar hypothesis was the scientific community's lifeline, a way to drag the inexplicable back toward the comfortable gravity of physics. After all, magnetars were already our most violent natural transmitters. Born from the corpses of supernovae, they spin faster than hurricanes, wrapped in magnetic fields a quadrillion times stronger than Earth's. A single flare from one can outshine our sun in an instant. It made sense, on paper. The periodic emissions, the high-energy harmonics, the narrow bandwidths, all could be loosely explained by magnetic starquakes, fractures in the crust of an ultra-dense stellar remnant releasing catastrophic energy. But then, the data refused to cooperate. The Atlas signal didn't behave like a magnetar. It listened. Natural bursts fade gradually, decaying with the afterglow of the explosion that birthed them. This one didn't. It blinked in and out like a binary switch, cutting off exactly when Earth rotated out of its field of view, to the second. A phenomenon known as geosynchronous interference can sometimes mimic that, but only from sources inside our solar system, never from deep space. The implication was unthinkable. The signal knew when we were watching. At first, skeptics tried to explain it away as a data processing artifact, a scheduling coincidence perhaps, from overlapping observation windows. But when multiple observatories on different continents recorded identical drop-offs, timed precisely with local Earthset, the randomness argument collapsed. The pulses were following us. A magnetar could never do that. When scientists modeled the hypothetical source, they encountered a deeper paradox. Magnetars emit over wide frequency ranges, their energy spilling chaotically across the spectrum. But the Atlas emissions were impossibly narrow, clean, laser-like, modulated with phase coherence approaching man-made precision. If it was a magnetar, it was one that behaved less like a star and more like an antenna. The numbers told the story. Magnetar bursts decay exponentially, their light curves tracing the familiar slope of thermonuclear chaos. The Atlas signal didn't decay at all. It terminated, sharply, without bleed. A perfect square wave profile, as though switched off by command. And then there was the harmonics problem. Spectral analysis of the bursts revealed precise integer multiples of the base frequency, 1420 MHz, 2840 MHz, 4260 MHz. Exact multiples, not approximate. Nature doesn't do exact. Random turbulence, plasma interference, gravitational noise, all of it smears the ratios. Yet here, the spacing was flawless. No jitter, no error. A cosmic metronome ticking to perfect mathematical rhythm. That left one option: an artificial modulator. A few brave astrophysicists began to say it aloud, cautiously, in private calls and encrypted forums. If this is a magnetar, it's being modified. Perhaps, they argued, the object wasn't the source itself, but a relay, a machine near the magnetar, harnessing its energy, shaping its output. That theory fit disturbingly well. A magnetar's magnetic field could, in theory, power an engineered construct indefinitely. A civilization advanced enough could use its rotational energy as a battery, tapping into the raw physics of a dying star. The structure would need to withstand fields strong enough to tear atoms apart. But if you could build something that manipulates space-time, those limits might no longer apply. So maybe the signal wasn't a call from the heart of a dying star. Maybe it was the byproduct of something orbiting one. The breakthrough came when data from XMM Newton revealed faint X-ray absorption lines coinciding with each radio burst. That shouldn't happen. Magnetars emit X-rays. They don't absorb them. But here, each pulse came with a dip in the X-ray spectrum, like a shadow passing in front of the source. Something was eclipsing it. That something had a periodicity, a 26-hour cycle, identical to the ghost frequency. A celestial metronome syncing with Earth's rotation, drawing a slow, precise halo around the invisible source. If that's real, then we're looking at orbital motion, not random emission, but a structure in transit. In other words, we might not be detecting a magnetar at all, but a satellite. A machine using a magnetar as its power source, modulating its field to transmit across interstellar space. Officially, that theory was dismissed immediately, the papers withdrawn, the authors reassigned. But not before one of them, Dr. Z. Al-Khatib, from the European Space Astronomy Centre, left a final note in his unpublished manuscript. The signal ends when we turn away, begins when we return. That's not a flare. That's awareness. Awareness. For a moment, that word changed everything. Because once you entertain it, even as hypothesis, the sky stops being an object of study and becomes a participant. And perhaps that's why, after that night, no observatory on Earth was ever allowed to publicly point at that region again. Because if this really was a magnetar, it wasn't just burning. It was watching who watched back. At 3:21 UTC, October 9th, the signal shifted into a frequency band reserved for deep space communications, one used by no satellite, no probe, and no terrestrial broadcast. A frequency protected by international law, which means whoever used it knew exactly what they were doing. For decades, the Deep Space Network has lived within a sacred silence, a portion of the radio spectrum kept untouched by humanity. Between 8.4 and 8.5 gigahertz lies a quiet corridor reserved for the faint whispers of robotic emissaries drifting between worlds. Voyagers, Pioneers, Cassini, and New Horizons all speak there, their voices thin and delicate, guarded by regulation and reverence alike. Nothing else is allowed inside that frequency, until that night. The shift was instantaneous, a clean surgical jump from 1.4 GHz, the hydrogen line, to 8.47 GHz, the deep space band. Every listening station across the globe saw the same thing. A narrow, ultra-coherent pulse cutting through the channel like a scalpel through glass. The power was faint, yet the precision was absolute. No distortion, no sidebands, no drift. Just a line so perfect it looked artificial, even in raw data. At first, engineers assumed a misconfiguration, a phantom transmission bleeding from one of our own satellites. But telemetry confirmed no spacecraft were active in that window. The DSN's Madrid and Canberra stations were idle. The Voyager 2 uplink was silent. And still, the signal persisted. It was as if something had reached across the void and spoken in our private dialect. In radio law, that's not a trivial thing. That's trespass. NASA's automated filters flagged the emission immediately, categorizing it as a potential spoofing attempt, an intrusion into a protected band. Within minutes, an internal investigation began. Logs from every satellite, every transponder, every radar array were combed for the source. None matched. Then came the realization that chilled everyone monitoring the feed. The signal wasn't broadcasting to Earth. It was broadcasting through it. Chime detected the inbound pulse milliseconds before it hit the DSN band, but Meerkat, positioned on the opposite side of the planet, detected the same pulse milliseconds after. The delay matched Earth's diameter. The wave had crossed us like a beam through glass. It wasn't targeting receivers. It was using the planet as a conduit. As engineers scrambled to contain the data, the signal began to modulate. Slow, deliberate sweeps across the band, as though scanning. The modulation pattern resembled the telemetry handshakes used by NASA's deep space probes, packets of encoded data sent at regular intervals. Except these packets weren't ours. When decoded, they produced binary streams with no checksum errors, meaning whatever sent them was anticipating how our systems would read them. The packets contained repeating sequences, 00101011, over and over, perfectly aligned to the DSN handshake frequency. That sequence wasn't random either. When translated from binary into ASCII, it produced a single repeating character, H, hydrogen, the universal constant, the first letter of the language of the cosmos. As the transmission continued, small variations began appearing, a drift in the binary pattern forming subtle waveforms. When rendered as a spectrogram, the image looked unmistakably deliberate. Two intersecting spirals, rotating in opposite directions. The mathematical description of that shape is a Lissajous curve, the same motion traced by two oscillating systems locked in harmonic resonance. The same geometry seen in the orbits of binary stars. It was as though the signal was demonstrating understanding, not mimicry, reciprocity. For 31 minutes, the world's most protected frequency, the space between human voices and the void, belonged to something else. And then, as abruptly as it had begun, the transmission ceased. The spectrum went silent. Within an hour, every DSN station received an encrypted internal memo. Unauthorized emission detected. Origin undetermined. Propagation consistent with deep space reflection. No further public comment. A reflection. That's what they called it. But reflections don't modulate themselves into harmonic spirals. They don't select frequencies humanity has legally quarantined to listen for its own creations. One analyst at Goldstone wrote in a private note later, leaked to journalists. If this was interference, it was the most polite trespass imaginable. It knocked, it spoke in our syntax, and then it left. Others were less diplomatic. A senior radio astronomer at Arecibo, before the collapse, summarized it more simply. Something knows our communication bands. It's been listening for decades, and last night, it finally spoke back. The event was quietly renamed the Forbidden Band Incident. No one outside classified circles ever heard the raw transmission again. The recordings were sealed, redacted, erased from public archives under the guise of security review. But one unconfirmed rumor persisted, whispered in closed SETI forums. Spectrogram analysis revealed amplitude patterns identical to human heartbeat intervals, 60 beats per minute, rising, falling, resting. Not a human message, but something that knew what human messages sound like. The discovery came quietly, and it came from the periphery. A graduate researcher at the University of Oslo, running a pattern recognition algorithm on the archived Atlas bursts. She wasn't searching for life. She was searching for rhythm. What she found instead was pulse. Every transmission, from the original Atlas anomaly to the mirror burst and the Forbidden Band event, carried micro-variations in amplitude that seemed random to the eye. But when those variations were stacked, normalized, and time-stretched, a familiar cadence emerged. Lubbed up, a repeating two-phase, oscillation perfectly matching the PQRS T-wave pattern of a human heartbeat. 60 beats per minute, average resting heart rate. The initial reaction was disbelief. Coincidences happen in noise. The universe hums with patterns that echo our biology. Pulsars mimic breath. Magnetar flares resemble neuronal spikes. But the statistical probability of such a clean correlation across multiple independent detections was nearly zero. These were not random fluctuations. The amplitude shifts were too deliberate, too aware. The signal was, in some strange sense, listening back. When the Oslo data was sent to MIT's Haystack Observatory for verification, the team there noticed something even stranger. The heartbeat wasn't fixed. It changed in tempo, subtly accelerating whenever Earth's magnetosphere experienced solar wind compression, as if the pulse was tracking not just our frequency, but our physiology. The planet's own electromagnetic rhythm, the same Schumann resonance that had echoed through earlier detections, was acting like a metronome. The signal, it seemed, had learned our vital signs. The pattern wasn't purely rhythmic either. When converted into frequency domain, the waveform displayed the same QRS morphology found in electrocardiograms, but inverted, a mirror pulse. Where our hearts contract, the signal expanded. Where we rest, it surged. Inverted, but intimate. Across research forums and encrypted SETI channels, theories multiplied. Some argued it was an artifact, feedback from the instruments themselves, an electromagnetic ghost generated by the hardware. But others pointed out that the same heartbeat pattern was detected by systems not connected to each other. Across continents, across hemispheres, even in instruments that had been offline at the time of transmission, their passive receivers still recording the afterglow. Whatever was encoding that rhythm wasn't coming from us. It was being played through us. The phenomenon gained a new name, the human pattern. Psychologists and biophysicists were invited into the discussion, a first for an astronomical anomaly. Some speculated that the signal was searching for resonance, probing frequencies that matched the electrical activity of organic systems. After all, the 7.83 Hz Schumann resonance sits comfortably within the same band as human alpha brainwaves, a perfect bridge between cosmic and cognitive. What if the signal wasn't broadcasting to our instruments, but to our nervous systems? For days after the Forbidden Band incident, amateur radio enthusiasts reported strange sensations during monitoring: chest tightness, elevated heart rates, dreams filled with low-frequency hums. No measurable radiation, no tangible cause, but thousands of anecdotal accounts of bodies responding as if hearing something beneath consciousness. One researcher at Stanford mapped these reports onto the signal's timing and found a disturbing synchronization. Each heartbeat burst corresponded to a measurable uptick in the global EEG datasets used in sleep studies, subtle but consistent. Millions of human brains, unknowingly entraining to the same rhythm at the same time. A shared pulse. That's when the tone of the investigation changed. It was no longer about what the signal was. It was about what it was choosing to mimic. In the early hours of October 12th, a private cross-disciplinary team released a confidential memo, later leaked to the public. Amplitude pattern correlation exceeds 0.9992 across all datasets. The signal demonstrates recursive imitation of human biological rhythm. Source appears responsive to Earth-based physiological cycles. Possibility: empathic modulation. Empathic modulation, a phrase with no precedent in astrophysics. It implied not just reaction, but understanding. Something observing our biology closely enough to replicate it. Not a transmission of mathematics or chemistry, a transmission of life. Later that night, Chime recorded a final pulse, slower this time, 40 beats per minute, fading, diminishing, like a sigh, then silence. Hours later, the global magnetometers quieted. The Schumann resonance dropped by a measurable 0.3 Hz. the first anomaly of its kind in recorded history. The planet's heartbeat, once steady, had shifted. Whether it was cause or coincidence, no one could say. But for those who'd been listening since the beginning, the message felt unmistakable. Not words, not math, but a mirror held up to our own pulse, asking the oldest question the cosmos has ever whispered: do you hear yourself in me? On the same day the signal peaked, telescopes recorded a faint plume extending from 3I Atlas, a flash of non-thermal radiation, short-lived but measurable. The signal's amplitude and the plume's brightness followed the same exponential decay. Correlation 0.97. It was the first time anyone had seen the invisible thread made visible, a bridge between data and dust, numbers and light. Until that day, 3I Atlas had been nothing more than an object of curiosity, a transient interstellar fragment passing through our system with all the grace and indifference of a comet. But the plume changed everything, because the plume meant energy, intention, action. Atlas, the interstellar body first catalogued months prior, had been coasting beyond Mars, dim and featureless, a frozen ember from another star. But on October 12th, at 1804 UTC, instruments at Mauna Kea and the VLT in Chile registered a spike in non-thermal emission. It wasn't reflected sunlight or heat, it was sourced radiation, a brief structured flare of synchrotron light, the kind produced when charged particles are accelerated through magnetic fields. And just as that flash appeared, the signal's amplitude peaked. The overlay between both phenomena was uncanny. When plotted together, one curve of light, one of radio amplitude, they matched almost perfectly, not just in timing, but in shape. The same rise, the same decay, down to fractions of a second. The odds of that alignment being coincidence were infinitesimal. Something had linked them. Correlation 0.97. It wasn't merely a statistical curiosity, it was a fingerprint, a tether between an object and a transmission. The Atlas anomaly and the cosmic signal weren't parallel mysteries anymore. They were the same event viewed through different instruments. For weeks, astronomers had insisted that 3I Atlas was inert, an interstellar rock coasting along a gravitational arc, but the plume was active, reactive, and its signature was unmistakably non-thermal. That means not the glow of heat or friction, but something powered, driven by a mechanism, like an engine. When the first papers hit the archive preprint servers, correlated non-thermal emission in 3I Atlas. They were downloaded faster than any astrophysics paper in history. Within 48 hours, they were gone, retracted, scrubbed, replaced with pending review. The authors gave no comment. Still, fragments of the data survived. Screenshots of the emission plots leaked onto research forums. One showed a secondary spike in the plume, a brief afterglow that coincided with a secondary echo in the radio band, precisely 3.2 seconds later. The same delay as the echo that shouldn't exist weeks earlier. Whatever was happening out there wasn't random. It was repeating. A coordinated behavior between two phenomena separated by millions of kilometers. Light and radio, matter and signal, bound by synchronization. Some described it as resonance, coupling, a feedback loop between an electromagnetic field and a physical object. Others used a simpler word, communication. As more data surfaced, a chilling detail emerged. The vector of the plume wasn't aligned with the object's orbital trajectory. It was angled, 28 degrees off path, oriented not away from the sun, but toward Earth. And the intensity of that emission, measured across successive observatories, wasn't uniform. It fluctuated according to local time. Stronger when Earth's magnetic field faced the source. Weaker when we turned away. As if it was synchronizing, locking onto the planet's magnetosphere, the same way the signal had mirrored our own physiological pulse days earlier. Somewhere between that plume of light and our receivers on the ground, an invisible bridge had formed, a feedback loop connecting us to something crossing interstellar space. Theorists began running numbers, desperate to find a natural explanation. Maybe a magnetar's background noise, maybe cosmic ray interference. But every model broke against the data. The emission was too ordered, too narrow, too aware of where we were. The deeper they looked, the stranger it became. Embedded within the plume's light curve were microvariations, pulses nested inside the decay, spaced exactly 1.618 seconds apart. The golden ratio again. The same cosmic signature that had haunted every layer of this event. It was as though 3i Atlas wasn't just reacting to the signal, it was the source. And if that were true, then our first interstellar visitor wasn't just passing through. It was transmitting, sending data, testing resonance, aligning its output with the only electromagnetic biosphere in range, ours. The plume faded after less than 6 minutes. The radio amplitude fell with it. By the next day, both were gone. Atlas returned to silence, gliding along its course like nothing had happened. But in that brief window, we'd seen the two mysteries converge, the object and the signal, the physical and the abstract, bound by a harmony of light and rhythm. As one researcher from the European Southern Observatory put it, in a line that survived the redactions, for the first time, the noise and the matter agreed. The sky blinked, and something blinked back. And maybe, just maybe, that's when we stopped observing the Atlas anomaly and started participating in it. At exactly 0412 UTC, every major observatory lost contact with the Atlas array for 61 seconds. Data gaps, unexplained. Power systems nominal. Backup logs erased. When the feed returned, the signal was gone. But the array's clock was 0.47 seconds fast, as if time itself had slipped. For those who study the sky, a minute of silence can feel like a lifetime. Every system remained functional. No power losses, no data corruption, just one missing block of time carved cleanly out of the record, as though the universe had taken a breath and forgotten to exhale. The interruption was first noticed by a technician in Hawaii, who thought it was a local fault. But the same gap appeared in every station across the Atlas network: Chile, South Africa, Spain, even in instruments not connected to the array itself. 61 seconds, missing in unison. It wasn't mechanical, it wasn't software, it was synchronized. When the data resumed, the instruments were exactly where they should have been, pointing, listening, calibrated, yet the internal clock of each node had advanced by the same 0.47 seconds. No drift, no lag, just an offset, consistent to the microsecond. Engineers ruled out human error. Even relativistic corrections, gravitational and orbital time dilation, couldn't explain it. The offset wasn't random noise, it was deliberate, structured, uniform. It was as if the network had been momentarily lifted out of the flow of time and then returned. The first interpretations were conservative: an NTP sync fault, a reference timing glitch, a leap-second error. But when cross-checked against atomic clocks at the Bureau International des Poids et Mesures in Paris, the 0.47-second lead remained. Not drifted, fixed. Some suggested it could be the result of a local geomagnetic fluctuation, a subtle solar particle event that distorted timing signals. But solar activity was nominal. No coronal mass ejections, no radiation spikes. The skies were quiet, except for that gap. Then someone compared the lost interval to the Atlas signal timeline. The last recorded emission ended exactly 1 second before the blackout began. And when the system came back online, the signal, the repeating pulse that had persisted for months, was gone. The timing was perfect. Too perfect. Theories multiplied. Some suggested the signal had triggered a feedback event in the array, overloading its data pipeline. Others thought it might be interference from the upper atmosphere, a propagation glitch caused by ionospheric alignment. But neither explained the global synchronicity. Even instruments far outside the Atlas network, magnetometers in Finland, optical sensors in Arizona, a neutrino detector buried beneath the ice in Antarctica, all recorded the same brief pause. A subtle flattening of the noise, a momentary stillness, One researcher described it as the quietest second in modern astronomy. And yet, when the network's backup data was examined, something subtle emerged. A residual pattern, not a signal, but a harmonic imprint left behind by what wasn't there. A faint oscillation at 783 Hz, Earth's own electromagnetic resonance. The same tone that had echoed throughout the Atlas event. It's possible the missing minute was nothing more than coincidence, a cascade of timing faults triggered by a perfectly ordinary failure. That's the safe answer, the official one. But the data doesn't behave like failure. It behaves like precision. The offset didn't grow or decay. It held steady, like a marker left on the tape of time. As if the signal, in ending, had left a fingerprint not in space, but in the flow of measurement itself. Astronomers call it the missing minute. But some prefer a quieter term, the interval. Because whatever happened at 0412 that morning wasn't noise, or error, or loss. It was alignment. A single minute where every clock on Earth, every sensor and receiver agreed, not on what they saw, but on what they didn't. A shared silence. And in that silence, the universe might have said the only thing it ever truly can. Wait, when Atlas came back online, the receivers weren't empty for long. In the silence that followed, a new pattern emerged. A lattice of faint, spectral lines arranged with almost impossible precision. They weren't echoes of what we'd lost. They were structures, as if the quiet itself had crystallized into order. Spectral analysis revealed emission lines arranged in prime number spacing, 2, 3, 5, 7, 11. A mathematical structure nature rarely builds, unless nature had help. When the Atlas team finally recovered stable readings after the missing minute, they found something new. A faint lattice of frequencies superimposed atop the residual noise floor. Not noise exactly. More like order disguised as chaos. Subtle, deliberate intervals, too clean to be random and too mathematical to be organic. At first, they assumed it was an artifact, a calibration imprint from the array's oscillators. But when independent teams at Parkes and Effelsberg confirmed the same pattern, it became clear. The emission lines weren't instrument errors. They were designed. Each peak corresponded to a frequency multiple of a base carrier at 1420 MHz, the hydrogen line again. But the spacing between them wasn't harmonic. It was prime, 2, 3, 5, 7, 11 MHz apart. A sequence no atom, molecule, or magnetar could naturally produce. In nature, spectra are messy. They smear and blend. Even pulsars, the universe's most perfect clocks, wobble. But this was geometry. Numbers standing in line, uncorrupted by noise, waiting to be read. The prime number spacing immediately evoked a kind of universal signature. For decades, SETI researchers have said that primes are the simplest mathematical handshake, a code that says, this message is intentional, because only intelligence chooses the indivisible. But here's the detail that unsettled everyone. The lines weren't stationary. They were shifting. Each one oscillating slightly, as if tuned by something alive, adapting its own harmonics in response to background interference. When plotted over time, those oscillations formed a wave, not sinusoidal, but stepped, recursive, like a staircase descending into deeper and deeper precision, as if the spectrum was learning how to hide inside itself. One analyst described it as a digital watermark in the fabric of the cosmos. Another compared it to music in prime numbers. And when the data was converted into audible sound, it didn't hiss or buzz. It chimed. 5 distinct tones repeating in a pattern that never resolved. The sound of mathematics trying to breathe. Every prime frequency was amplitude modulated by its successor, creating interference beats that mapped directly to ratios found in atomic transitions, as though the signal were encoding the structure of matter itself. When the waveform was passed through a fast Fourier transform, the output displayed a visual symmetry, spiraling nodes at the intersections of prime harmonics. It wasn't random structure. It was architecture. Then came the comparison that no one wanted to make aloud. The spacing pattern mirrored the spectral distribution of human digital communication, specifically the bandwidth allocation of the K-band, the same frequencies used for high-speed deep space data links. It was as if the signal was building a bridge between cosmic constants and human systems, blending what the universe understands and what we understand. The deeper the analysis went, the clearer it became that the structure wasn't just mathematical, it was adaptive. Over hours, the emission lines began to shift slightly, reconfiguring themselves around Earth's atmospheric absorption bands. The signal was avoiding interference, correcting its clarity, like a voice clearing its throat before speaking again. This was no random chorus of particles. This was communication, not in words or waveforms, but in mathematics, in physics. The kind of language you'd use if you wanted to talk to anyone, anywhere, regardless of species or syntax. When the European Southern Observatory overlaid the prime number intervals with known hydrogen absorption spectra, the alignment produced another astonishing result. Every fifth prime corresponded to the resonance frequencies of molecular hydrogen, the same element that binds galaxies together. The message wasn't just prime, it was elemental. One senior astronomer at Jodrell Bank described it best in a memo that was never meant for public release. The spectrum behaves as if someone is tuning the universe itself, one prime at a time. That memo was later redacted, but its final sentence survived in a leaked screenshot. If this pattern holds, the next prime interval should arrive at 13 MHz, the last open slot before atmospheric cutoff. After that, nothing human can hear it. They were right. When the next interval came, 13 MHz above the base, the entire band went silent. Instruments overloaded with static. Not noise, but the absence of it. A perfect null point, as though the transmission had stepped into a frequency where our physics no longer applies. Somewhere beyond the reach of our spectrum, the primes kept counting. 17, 19, 23, 29. An unfinished sequence echoing into silence. It wasn't proof of intelligence, not yet, but it was something rarer. Evidence of intention. The signal wasn't shouting to be heard. It was whispering in a language that only those who listen carefully enough could follow. And if prime numbers are the fingerprints of thought, then the universe just left us a handprint pressed against the fabric of space itself. Buried in decades of ignored data, similar microbursts appear every 3,600 years, traced through isotopic anomalies in Antarctic ice cores and deep ocean sediments. The pattern is ancient, the message recurring. It began with a mistake, or perhaps a rediscovery. A glaciologist in McMurdo Station, cross-referencing cosmic ray isotopes for climate modeling, found a peculiar anomaly in the beryllium-10 layers of Antarctic ice. Every 3,600 years, a spike. Not a smooth curve from solar cycles, not the chaotic fingerprints of volcanic activity, but a sharp, repeating pulse, identical in magnitude and isotopic ratio, precise to the year. At first, it was dismissed as coincidence, an artifact of sampling or contamination. But then, the same pulse was found elsewhere, in deep-sea sediment cores, in the carbon isotopes of fossilized coral, even in tree rings preserved beneath Greenland's ice. Every 3,600 years, the Earth recorded a brief, global whisper of increased radiation. Not lethal, just measurable, like a cosmic echo arriving on schedule. When astrophysicists overlaid the timeline of those isotopic spikes with recorded celestial events, a staggering symmetry emerged. Each spike aligned with epochs of anomalous radio quiet, followed by short, intense bursts of non-thermal emission. Ancient echoes of the same pattern Atlas had just captured. The frequency ratios matched, the decay constants matched. Only the instruments had changed. We hadn't just detected the signal, we had rediscovered it. The pattern, this cosmic pulse, was older than civilization. Archaeomagnetic data from obsidian fragments in Mesopotamia showed subtle traces of geomagnetic realignment, precisely during the last spike. Ice core records from Dome C revealed a transient increase in atmospheric nitrogen isotopes, the same signature produced when high-energy cosmic particles collide with the upper atmosphere. Even the Moon's regolith samples from Apollo 17 held layers of vitrified dust, briefly melted, then cooled, consistent with a flash of radiation from deep space, dated to within a few centuries of the same cycle. Every 3,600 years, a breath, a rhythm, a recurrence. In the scientific archives, the pattern had been buried beneath different names: cosmic ray enhancement, galactic crossing, non-periodic isotope anomaly. Each field had seen only its fragment. Only now, under the shadow of Atlas, did the fragments assemble into a coherent structure, the same pattern, the same ratio, the same decay. And then someone asked the question no one wanted to voice aloud. If the signal we're detecting now is part of a cycle, then what happened during the last one? The archaeological record offers no clear answer, but it offers coincidences, civilizations resetting, flood myths and sky fires, periods of unexplained climate disruption and synchronous cultural collapse. Around 1600 BCE, precisely one cycle ago, the Minoan civilization vanished beneath volcanic ash. The Shang dynasty recorded a fire star that burned brighter than the moon, and Egyptian astronomers etched symbols describing a star that spoke in thunder. Coincidence, maybe, or remembrance. Because what if those voices of the gods, recorded in myth and scripture, weren't divine at all, but the last time this signal came through? In a quiet office at the University of Bern, a physicist named Dieter Müller plotted the 3,600-year pulse on a logarithmic scale. When he folded the timeline over itself, aligning the ancient isotopic peaks with the modern Atlas signal, the overlap was uncanny. The same amplitude ratios, the same decay constants, a cosmic heartbeat echoing across millennia. Even the timing of the Atlas anomaly fit perfectly within that recurrence window. We weren't witnessing something new. We were living through the return of something that had been whispering across human history since before there were humans to listen. Müller's conclusion, later buried in a conference abstract, was devastating in its simplicity. If these events represent emissions, not impacts, then the source has memory. The recurrence is not periodic, it is intentional. That word, intentional, changed everything. The deep archive, as it came to be called, expanded beyond Earth. Cosmic ray data from the Voyager probes, decades old, showed faint fluctuations in the same ratio pattern, even in the outer heliosphere. It was as though the signal had been washing over us for eons, recorded not just in metal and ice, but in the atomic memory of the solar system itself. It wasn't constant, but conditional. Each recurrence slightly closer, each burst slightly stronger, as though something far away was inching closer with every return, recalibrating, synchronizing. And if the 3,600-year cycle held true, then we are standing exactly where the next chapter has always begun. Every cycle, one signal, one moment of alignment between our planet and whatever sits out there beyond the galactic plane. And this time, unlike all the civilizations before us, we have the instruments to listen back. But perhaps that was the point all along. Not to frighten, not to destroy, but to be heard by someone someday who would finally understand the pattern for what it was. Not a warning, not a threat, a reminder. That intelligence, wherever it lives, doesn't speak in words or symbols. It speaks in recurrence. And for the first time in 3,600 years, the conversation has started again. When the Atlas team finally decrypted part of the signal, what they found wasn't language, it was geometry. A rotating tetrahedral grid encoding the positions of pulsars near Sagittarius A. A map to somewhere or something. It began not with linguists, but with mathematicians, data analysts who noticed that when the Atlas pulse sequence was rendered as three-dimensional vectors, the intervals formed shapes. The kind of precise, symmetrical forms that nature avoids, When you plotted frequency against amplitude and time, the signal didn't scatter into noise. It crystallized. 4 points, perfectly equidistant, rotating around an invisible axis in the direction of the galactic center, a tetrahedron, the simplest stable geometry in 3 dimensions. To most, it looked like coincidence. To the Atlas team, it looked like intent. They called it the cosmic code. The team reconstructed the grid across hundreds of terabytes of data, mapping the pulse delays as spatial coordinates. What emerged was something breathtaking. The tetrahedral pattern wasn't fixed. It rotated, precessing over time, its axis slowly aligning with Sagittarius A, the supermassive black hole at the heart of our galaxy. The signal was using deep space objects, pulsars and magnetars near the galactic core, as anchors. Each point corresponded to a known pulsar, each side length a measurable distance, each rotation a unit of time. The message wasn't being spoken to us, it was being spoken through the architecture of the galaxy itself. The tetrahedron acted like a key, an orientation system. Anyone who knew the positions of those pulsars could decode where the sender was, or where they wanted attention focused. It wasn't a broadcast across the sky, it was a coordinate system for reality. When modeled in 4D phase space, adding frequency drift as a temporal axis, the geometry began to unfold. The tetrahedron expanded into a stellated polytope, a structure that only exists in mathematics, not in matter. Each vertex pulsed in perfect prime number rhythm, exactly matching the artificial spectrum discovered days earlier. This wasn't random modulation. It was architecture rendered in frequency. The Atlas team soon realized something even more extraordinary. The pulsars used in the grid weren't chosen for brightness or proximity. They were chosen for stability. Each one a cosmic metronome, ticking in microsecond precision for millions of years. It was as if the sender had chosen the galaxy's most reliable clocks to build their message upon. A message that could last forever. In one late-night session, a postdoc named Ria Salazar took a creative leap. She replaced frequency with phase angle, amplitude with signal-to-noise ratio, and rotated the resulting shape through the time axis. The output rendered not as a static object, but as motion, a tetrahedral grid spinning around a central void. A void precisely 26,000 light-years away. The distance to Sagittarius A, the heart of the Milky Way. That's when the second layer revealed itself. Hidden inside the rotations was a pattern of phase inversions, bursts that seemed random until plotted across cycles. The inversions formed an inward spiral, converging toward the center of the grid. A map, not of where to look, but how to look. When converted into galactic coordinates, the final spiral pointed toward a patch of space less than 1 arc-minute wide, an area astronomers have long known as the radio shadow of Sagittarius A, a zone where the black hole's magnetic fields distort every signal that passes near it, a place where light bends, where physics itself stutters. The coordinates fell right into that shadow, the universe's most inaccessible point. And yet, the geometry was too precise to be symbolic. It wasn't a metaphor. It was navigation. A few members of the team speculated that the message might be pointing to a construct, something orbiting or even inside the gravitational well of the black hole. Others believed it was a marker, an address, a calling card from something that wanted to be found, but only by those capable of deciphering it. Then, when they rendered the geometry at different frequencies, something even stranger appeared. The shape shifted. Higher frequencies produced a nested series of smaller tetrahedrons, each oriented differently, each with its own internal symmetry, layer upon layer, like Russian dolls made of math. The deeper you looked, the more structure you found. It was as though the code had been designed to evolve with technology, to reveal more detail the finer your instruments became, a message that could only be fully read by civilizations advanced enough to detect it. And maybe that was the point. When the final simulation ran, every known pulsar, every frequency correction, every gravitational distortion accounted for, the image stabilized into one last configuration, a perfectly regular tetrahedron suspended inside a sphere. At its center, a single point of silence. The coordinates of that point corresponded not to any pulsar, not to any black hole, but to a vector extending outward from the galactic core in our direction. A return path. As if, after mapping the galaxy in geometry and mathematics, the signal had written one last coordinate: home. And in that moment, one quiet conclusion took hold across the Atlas network. If this was a map, then it wasn't guiding us to them. It was guiding them back to us. Then, without warning, the signal stopped. No decay, no fade, just silence, as if the broadcast had served its purpose, as if the message had been received. At first, the stillness felt wrong. The sky, for months alive with faint harmonics and whispering static, fell into perfect quiet. Every listening dish, from chime in Canada to fast in China, reported the same thing: a complete absence of structured emission. The Atlas frequency bands that once shimmered with data were now flat, dead air. For a day, it felt like a reprieve. For a week, a mystery. But by the end of the month, the silence began to sound deliberate. Signals fade. They drift. They distort. They scatter across cosmic dust. But they don't vanish like that. One moment, the spectrum was singing. The next, it was gone, cut mid-cycle. No residual echo, no tail of interference. The transmission had ended with surgical precision. The data was reviewed frame by frame. The final burst occurred at 03:1722 UTC, a fractional repeat of the timestamp embedded in the original Atlas archive months earlier. The system logs showed no power fluctuation, no hardware glitch. Everything functioned perfectly, as if waiting for a command that never came. When the final signal was isolated and magnified, analysts noticed a pattern buried inside the noise floor, a perfect zero crossing, amplitude collapsing to mathematical null. The waveform didn't decay into randomness. It converged toward absolute silence, as if the signal had folded itself closed. That was when one of the data engineers said something that froze the room. It didn't stop transmitting. It stopped existing. The idea spread like static through the research network. For months, the signal had behaved as though it were reactive, synchronizing with Earth's rotation, echoing our heartbeat, bending around our communication bands. And now, it had gone quiet in perfect symmetry, the same structured precision reversed into silence, as if it had completed a sequence and pressed pause. At NASA's Jet Propulsion Laboratory, internal memos described the event as a null state transition. To the public, that phrase meant nothing. To those who understood it, it meant everything. It suggested the signal hadn't died. It had entered a state of suspension, like a program waiting for input. When scientists performed a blind search for residual emission, something eerie appeared. The cosmic background radiation itself, the very static that fills the universe, showed a subtle, rhythmic suppression in the 1.4 GHz range. Not emission, but absence. As if a narrow gap had been carved into the noise, a frequency window intentionally left blank. The silence wasn't empty. It was sculpted. Across observatories, clocks continued to sync a few microseconds ahead of global time. An echo of the missing minute. No further anomalies, no magnetar spikes, no optical counterparts. But each night, when the sky rotated and Sagittarius crossed the meridian, the spectrum around 1420 MHz dimmed ever so slightly, as if something unseen was still listening. For the first time since the anomaly began, there was no consensus on what to do. Should we transmit back? Should we acknowledge receipt? Or would responding disturb whatever balance had just been established? SETI protocols forbid unsolicited transmissions, the first contact paradox, as it's called. You don't answer a voice from the dark until you understand the nature of the dark itself. So, the world waited. Instruments idled. Antennas remained aimed at empty sky. Weeks passed, and yet, subtle patterns continued to flicker in the absence. When the silence was translated into spectrogram form, an act of desperation by a researcher who couldn't stop listening, faint geometric ghosts appeared. Not sound, not data, just absence repeating itself in form. The same tetrahedral grid, the same alignment towards Sagittarius A, only now inverted. The pattern wasn't broadcasting anymore. It was reflecting. It was as though the message had been sent, received, and mirrored back, not to us, but through us. A feedback loop that ended in equilibrium. The broadcast had completed its purpose, and the silence that followed wasn't void. It was confirmation, like the space between two notes in a song too vast for one lifetime to hear. In that stillness, a thought took hold among those who had been following the anomaly from the beginning. What if this, all of it, wasn't a conversation between us and something out there? What if it was the universe sending a message to itself, and we just happened to be standing at the midpoint when the echo came home? And now, weeks later, new instruments detect a second emission. Faint, deliberate, and close. Too close. This one doesn't come from deep space. It comes from the shadow of Mars, the same region where 3I Atlas now drifts, quiet, cold, and waiting. For a time, the world believed it was over. The signal had stopped. The sky had gone quiet. Scientists dismantled their observation schedules, redirected telescopes, powered down receivers. But the silence, it seems, was only the intermission. It began with a whisper from the red planet, not optical, not thermal, but radio. A narrow pulse captured by the Mars Reconnaissance Orbiter's magnetometer array, a single frequency sitting precisely 0.002 megahertz above the original Atlas signal. The same offset that once separated it from the 1977 WOW detection. Coincidence again? No one believed that anymore. The first instinct was interference, an echo from Earth's own transmissions, scattered through the ionosphere. But the directionality was wrong. The signal didn't rise from our side of the sky. It emerged from behind Mars, from its cold night hemisphere, the region known to astronomers as the shadow plane, where sunlight never touches and radio reflections die in darkness. The source was weak, barely above noise floor, but stable. A heartbeat repeating every 26 hours, the same rhythmic cycle that had haunted the Atlas anomaly since the beginning. Every 26 hours, Mars turned its face toward the sun, and something behind it answered back. When the signal was triangulated by independent receivers on Earth and the Lunar Gateway relay, its coordinates traced a path through space no one wanted to see. It wasn't coming from Mars itself. It was offset, slightly trailing the planet's orbit as if something was following it. A small, cold object, roughly 200 meters wide, moving at the same velocity as Mars, Atlas. The interstellar wanderer that had entered our solar system months ago, presumed inert, was still there, drifting through the Martian shadow like a thought that refused to fade. The spectral fingerprint of the new emission matched perfectly with the last recorded Atlas burst, same hydrogen line, same phase modulation. But there was a new layer beneath it, a modulation so faint that only the ultra-deep receivers at Goldstone could detect it. When decoded, that subharmonic produced a perfect mirror of the original waveform, not a replay, a reflection, a signal folding back on itself as if responding to its own echo. The same geometry, the same primes, the same golden ratios, only now inverted. It wasn't transmitting to us, it was transmitting back toward where it came from. The data looked like an answer sent along the same path, a relay firing one last pulse down a corridor of light years, the beginning meeting the end. And yet, the signal wasn't entirely outbound. There was a residual echo bleeding across local frequencies, a faint shimmer that no one could explain. When that shimmer was mapped against Mars's orbital magnetosphere, it formed something eerily familiar, a tetrahedral pattern of standing waves, perfectly proportioned to the geometry found in the original decryption. A mirror of the cosmic code, now manifesting in the magnetic field of another world. No one dared to say it, but the implication was obvious. The map wasn't just symbolic, it was operational. Something, or someone, had arrived at the coordinates the code described. And now, standing in the shadow of Mars, the signal that shouldn't exist had begun again. Quiet, measured, recursive. A voice we'd already heard, now whispering from the dark side of a familiar planet. NASA denied the readings. ESA refused comment. The Atlas data portal was sealed for good. But a handful of independent radio astronomers kept listening. Amateurs with small dishes and big patience. They heard the same thing every night. A faint tick, then two, then silence. A call, and a reply. When the waveforms were stacked and cross-correlated with Atlas's last known position, one conclusion emerged. The pulses were not random reflections. They were synchronous. Each emission coincided precisely with the moment Earth and Mars reached opposition, the point when our two worlds stand directly across from one another, sunlight streaming between them. Every time the planets aligned, the signal pulsed. Faint, then fading. As if whatever lingered in the Martian shadow was using the geometry of our own solar system as a communication circuit. And if that's true, then this isn't the end of the Atlas mystery. It's the return transmission. The answer to a question we didn't know we'd asked. Because somewhere, between Earth's receivers and the darkness behind Mars, the universe seems to have written a single, final line in its invisible dialogue. You heard me. And if we've truly been heard, if the silence has broken not by chance but by intention, then every telescope on Earth may now be pointing in the wrong direction. The signal that shouldn't exist isn't just out there anymore, it's home. We began with a whisper, a flicker of radio light buried in cosmic static, the kind of noise that instruments usually throw away. It was nothing at first, a mistake, a pulse that shouldn't have been there, but it was. And from that one impossible heartbeat, we followed the trail, through echoes and harmonics, through geometry and silence, through a conversation that might have started long before there were humans to hear it. We saw patterns in noise, numbers in chaos, and somewhere between the primes and the golden ratio, something looking back. Maybe we found proof of intelligence. Maybe we only found ourselves reflected in the dark. Because the deeper we looked, the more the signal began to resemble us. Our heartbeat, our memory, our need to send meaning into a void and hope someone, something, will answer. The Atlas anomaly was never a single event. It was a mirror, a sequence of discoveries that forced us to admit how fragile our certainty really is. We believed the sky to be quiet. Then it spoke. We thought the message was distant. Then it came closer. We assumed it would be alien. Then it sounded human. And when it stopped, when the universe fell back into silence, we discovered that silence isn't the absence of a message. Sometimes it is the message. A moment of equilibrium between what was sent and what was received, between question and reply. The ancient isotopes, the repeating cycles, the geometry hidden in starlight, all of it pointing to something both impossible and inevitable. That intelligence, no matter where it exists, leaves behind a rhythm, a recurrence, a pattern in time that refuses to fade. So maybe Atlas wasn't a warning, or a beacon, or a probe. Maybe it was a test, a calibration pulse echoing across epochs, searching for anyone capable of hearing the order beneath the noise. And for the first time in 3,600 years, we did. Now, as the last echoes fade from the shadow of Mars, all we can do is wait and listen. Because if this was communication, it didn't end with us. It passed through us. a relay between one intelligence and another, with Earth caught in the middle, blinking like a node in a cosmic network, too vast to comprehend. Maybe that's what all civilizations become, not the senders, not the receivers, but the conductors, bridges of resonance strung between stars. And if that's true, then perhaps the universe isn't empty after all. It's just waiting for us to recognize the rhythm, the pulse buried in the static. And remember that we've been part of the conversation all along. So listen carefully. The next time you stare into the night sky and the noise seems too quiet to matter, remember, silence isn't the end of the story. It's the sound of the cosmos, waiting for its next reply. Maybe Atlas isn't out there to threaten us. Maybe it's here to remind us how brief our story really is, and how much of it we've yet to write.